Welcome to the video for lesson 10.2, where we are going to be using angle measures to find arc measures. So the first thing we want to do is take a look at the vocabulary that we're going to need for this lesson, and we're going to need the couple of them here. So a central angle of a circle is an angle whose vertex is the center of the circle. So let me just outline here on this diagram what the central angle is. So the center of the circle C is the vertex of the central angle that we're talking about there. The second vocabulary term, a semicircle, is an arc with endpoints that are the ends of a diameter. So I think we had something like this on a previous kind of an introductory assignment that we did, and so you should be familiar with a semicircle, and also remember that a semicircle has a measure of 180 degrees, half of a circle. And then when we're talking about minor arcs, let's read this through. It says, if the measure of angle ACB is less than 180 degrees, then the points on circle C that lie in the interior of angle ACB form a minor arc with endpoints A and B. So this is a minor arc because its measure is going to be less than 180 degrees. So let's just put a little reminder here. A minor arc is less than 180. And when we're talking about a minor arc, remember that we call that arc AB, and it's just two capital letters with the little arc over top of it is how we make the notation for arc AB. Now, the difference between a minor and a major arc is going to be that this is going to be, the major arc is going to be greater than 180 degrees, and we would actually write that with three capital letters. So if we read this, the points on circle C that do not lie on minor arc AB form a major arc with endpoints A and B. So let's name the major arc in the diagram. That diagram shows major arc ADB. And again, we would put the little arc symbol over it. We could also call that major arc BDA. All right, so it starts and ends on B and A. D would just be that middle letter to show that we're talking about the major arc, and that major arc is more than 180 degrees. Let me just go back up here and talk about semicircle again. A semicircle will be named with three letters also. That's just, a side note to how we notate the semicircle. All right, let's move on to the measure of a minor arc is the measure of its central angle. So whatever the measurement of the central angle is, that's also the measure of the minor arc. So let's take a look over here. The measurement of this angle is also going to be the measurement of the minor arc. So if I approximate my minor arc here, my central angle, to be 80 degrees, so the shaded blue angle is 80 degrees, which also means then the minor arc AB is 80 degrees. I want to take the difference of 360 and my 80 degrees to find out what my major arc is. Remember, we're talking about the measurement of a major arc. So 360 minus 80 is going to be 280 degrees for the major arc. So it's really just a subtraction problem there. All right, let's take a look at postulate 23, which is about arc addition. So the measure of an arc formed by two adjacent arcs, remember adjacent means next to, is the sum of the measures of the two arcs. We're going to have some practice problems to help us learn that postulate. Congruent circles are two circles with the same radius. So if the radius is the same in two different circles, then those circles are congruent. Last thing we have in our vocabulary section is congruent arcs. These are two arcs with the same measure that are the arcs of the same circle or of congruent circles. So if the circles are congruent, then if the arcs can be shown to be congruent, then those arcs are the same, have the same measure. All right, let's take a look at a couple of example problems. in example 1, it says find measures of arcs. So remember, two letters, two capital letters like we have in part A, is going to mean we're looking for a minor arc, and that one would have to be less than 180. So remember, as you're looking at the name, you should be sort of thinking about what the measure could be. Okay, now we can't tell if B and C are semicircles or major arcs just by looking at their names, but if we go over to the picture, we should be able to tell this is half of the circle, right? And then also this is half of the circle. Because there's not half of the circle, or sorry, there's not a point on this half of the circle, we're probably not going to be dealing with this half. However, it does look like KLM is going to be a semicircle. So that looks like for part C here, this is equal to 180 degrees. You don't have to write semicircle if you notice that, but you do need to remember that a semicircle is 180 degrees in terms of its measure. So it looks like this one here is going to be greater than 180 degrees. So let's go ahead and take a look at what they have marked on the diagram for us. For part A, they're asking us to find out the arc measure of LM. Okay, well, if the central angle is 125 degrees, then the arc measure is also 125 degrees. So LM is equal to 125 degrees. It's always equal to the central angle. So if we know that's 125, but we want to find the major arc called LMK, then we are going to have to figure out what this measure is right here first, because LMK starts at L, goes through M, and ends at K. All right, so if we know that this is 125 from L to M, and this is 180 from M over to K, we could add up 125 plus 180. So the measure of arc LMK is 305 degrees. We just have to add the two arcs that we know to get that final answer. All right, so let's take a look at some of these practice on your own problems down here. So you're going to do numbers 1 through 6. It first says to identify the given arc as a major arc, a minor arc, or a semicircle. So that's the first thing I need you to do. And then I also want you to find the measure of that particular arc. Now, the first thing you want to do is you want to start off by finding this little piece here. Remember that the central angle, which they have marked on the diagram for you, is going to be the measure of that particular arc. So if this central angle is 50, then that means the arc BC is 50 degrees. So down here, this is going to be a minor arc, and it is 50 degrees. All right, so you're going to need to find this arc AB because it doesn't have a number in there for you. All right, take some time to finish those other 5 problems there, please. All right, we're going to be on the back side of the page now for example number 2, which again asks us to find measures of arcs. It says here several students were recently asked about their favorite color. The results are shown in the graph. Find the indicated arc measures. All of the numbers on this graph over here tell us the percentage or the degree of that particular wedge of the circle graph. Okay, so green is 15%, sorry, not percent, degrees. So looking at the measure of RT, arc RT is a minor arc because it just has 2 letters and it's going to be less than 180 degrees. All right, so they're asking us to pretty much add up the blue and the green. Okay, if blue was 120 and green was 15, we can add those two together. And again, this is just adding 2 arcs together, which was one of our theorems or postulates on the other side of the page. 135 degrees. And for part B, it's asking us to find PRT, the measure of arc PRT. Now that could be a semicircle or it could be a major arc. We have to start on P, so put your pencil on P, and we have to go through R, and then we're going to land on T. Okay, so whatever we don't cover with our pencil is what we could subtract from 360. It looks like the section, the number of people that have black would be 75 degrees of our circle. So let's subtract that from 360 because we're just going to eliminate that from our answer. So our final answer would be 285 degrees. Rather than adding them all up, we can just subtract the thing that is not included. All right, for part C, we have to start on R, and we have to go through T, we have to land on Q. So put your pencil on R, we have to go through T, and we're going to land on Q. Okay, which section is not included? That's the one that's 100 degrees, or red it looks like. So let's subtract 100 from our total, because we're not including that in our major arc. So 260 degrees would be the measure of that arc, RTQ. The final question here is asking us to find the measure of STQ. So again, start at S, go through T, that's the middle letter, and land on Q. And it looks like we are not including this 15-degree section or this 100-degree section, so we're not going to include those two. And 100 plus 15 can be subtracted from 360. So I'm just going to subtract 115, which gives me the final answer of 245. So you can either add all the sections together or find out which sections are not included and subtract those from the total 360. All right, so you're going to do the problems 7 through 12 next. And use the diagram over at the right. If I were you, I would find the measure of arc AB to start this. I'm going to give you a little hint that the diameter is this EC here, and so that means that this entire half is going to add up to 180. That should help you figure out what this is to start with, right? If you have a 35 degree section and a 70-degree section of the circle already indicated to you, then you should be able to find out what arc AB is. All right, those shouldn't be too difficult. Try all of them, please, and then we will check them in class. Up next is going to be example 3, where we have to identify congruent arcs. It says here to tell whether the highlighted arcs are congruent, and then we also have to explain why or why not. I just want to remind you that congruent circles are two circles with the same radius, and congruent arcs are two arcs with the same measure that are arcs of the same circle or of congruent circles. So either the arcs that are congruent have to be in the same circle, let's say for instance like picture B here, so these two arcs that they're asking us about are in the same circle, or the arcs would have to be in two separate circles with the radius that is the same. So for instance, part C will have that. Let's take a look at part A. These two diagrams here show us that the radius of this circle is 7 and the radius of this circle is 5. All right, we need to find out if arc AB and arc CD are congruent. So based on the fact that the circles are not the same, the circles are not congruent, we would have to say that arc AB and arc CD are not congruent. So we're just going to say no, circles are not congruent. Remember, the radius has to be the same length in order for the circles to be congruent. All right, for part B, because these are in the same circle, these arcs are going to be congruent because they're actually vertical angles, aren't they? The central angles would be vertical. Those two are the exact same. So we can say yes, vertical angles, and so therefore the arcs are the same exact measure as well. All right, for part C, we have two pictures here. It looks like the radius is x in both of them. So no matter what value we would pick for x, let's say 10. Well, then this one would be 10 over here, and this one would be 10 over here. So if the variable represents the radius, and the variable is the same in both of them, then we can say, yep, these arcs are congruent to each other because the radius is the same in each one. So we'll say yes, circles are congruent. Circles are congruent. So you're going to practice on your own. The last couple of problems here, it says tell whether the highlighted arcs are congruent, explain why or why not. So the only way that that can happen is if the radius is the same between the two circles, or if it's in the same circle that they're asking you about. Okay, so if there's only one circle in the picture, then, you know, the arcs could be the same if they were like part B up here where we had the vertical angles, or if there's two separate circles, remember the radius would have to be the exact same in both of them. All right, we'll take questions in class. Thanks for watching.